With that, without further ado, I'd like to turn over to Madison Condon, one of our affiliated faculty from the law school here at Boston University, who suggested to us this paper as a really timely conversation to our IMAP series, and she will then introduce our featured speaker of the day. So Madison, over to you first.
Hello, everyone in the room and everyone online. Thank you for having me. I'm just going to very briefly introduce Sandy so we can dive right into the subject matter of the day. Sandy Trust is passionate about climate change and sustainability. His personal mission is to help reconnect finance and the economy to nature and the biosphere to deliver a future worth living in. Sandy Trust leads the UK's Institute and Faculty of Actuaries research paper collaboration with Earth system scientists on climate change and sustainability topics. Recent papers include the Emperor's New Climate Scenarios, which I have in my hand, and the Climate Scorpion. This thing is on it. Sandy sits on the IFOA Council and is a past chair of the Institute and Faculty of Actuaries Sustainability Board in the UK. I am very excited about this set of papers. Sandy's going to have a lot of very interesting information to share with us. So without further ado, I'm going to turn it over to Sandy. Thank you so much for being here, and I really look forward to your talk.
Fantastic, thank you, and massive thank you for the invitation. Great to be with you. I have absolutely no idea how many people are in the room. I can't see you, so hopefully you can see me and find this interesting. So yeah, thanks so much for the invitation to be here today. I'm going to cover climate scorpion, but also Emperor's New Climate Scenario. So I will touch on Emperor's New Climate Scenarios and why lots of financial services climate change analysis is understating risk, and also pick up on climate scorpion. Why should actuaries work with a system scientists? Why do we need to? And then talk about the way that climate risks are evolving, and then some of the really concerning findings around sensitivity. Just how sensitive is the planet to greenhouse gases, because that's a very critical assumption. I'm going to finish by talking about planetary solvency. So how could we adapt financial services solvency management techniques to help us to kind of manage the planet within planetary boundaries? So there we go. I'm deeply conscious. I don't know the level of expertise kind of in the room on these topics. I'm probably assuming some familiarity, but do jump in, ask questions, put your hand up, etc. if things are not clear. So what do I mean by this? We need to have a best guess about the worst case and make policy on that basis. We are all risk managers. I bet most of you crossed the road today, and I bet when you crossed the road, if you saw a bus coming or a car, you didn't wait till the very last second and sprint as quickly as you could, hoping you'd just make it. Of course you didn't. You don't want to be run over by a bus. Similarly, if you're crossing a river, you might say, well, how deep is the river? And I might say, well, the average depth of the river is half a meter. Would you cross? I mean, that is quite deep, isn't it? But would you cross the river? You don't really actually care too much about the average depth of the river. You care about the deepest part of the river. Is there a deep pool 2/3 of the way across? And is there a crocodile in that pool? That's what drives your decision. Not suffering the kind of worst case. So this was our central message. We need to think carefully about the worst case. What are the downside risks of climate change? What's the tail risk? And make policy on that basis. So yeah, just to touch on this string of papers, actuaries actually worked with Earth system scientists back in 2015, climate change, a risk assessment. That was at the time the only real risk assessment of climate change. And as I said, thinking about that river analogy, thinking about what the tail risks are, and rather than the kind of best estimates, and that was a UK, US, Chinese, and Indian government initiative, and anecdotally quite important in accelerating climate change policy in India and China. The chief scientific advisor to the UK government, Sir David King, led on that. And in 2021, we, a group of actuaries, met Sir David. And I was like a fanboy. Oh my God, it's Sir David King. And we said to him, well, why don't we do a paper? And he was extremely enthusiastic and generous about actuaries. And so we wrote Climate Emergency Tipping the Odds in Our Favour, COP26 policy briefing. And the central message from that was that climate change is a risk management problem. If we trigger multiple climate change tipping points, that's going to potentially impact human prosperity, therefore a risk management problem on a global scale. We went to Exeter University, went to the Global Tipping Points Conference, organised by Tim Lenton, Mr. Tipping Points. And at that point, there was lots of concern that financial services climate change analysis simply wasn't realistic. It wasn't capturing downside risks. So we wrote Emperor's New Climate Scenarios, and that really was saying many commonly used climate change scenarios are significantly underestimating climate risk. A particularly worrying, and that went quite viral actually, a particularly worrying finding in Emperor scenarios was this assumption climate sensitivity, just how sensitive is the Earth to greenhouse gases. And actually, when we dug into that, it's a very uncertain assumption. It's a very wide range. So that's why we wrote Climate Scorpion, because we're essentially making climate policy on the average depth of the river. That I don't think is particularly sensible. So it's been an enormous privilege to work with some really outstanding Earth system scientists and put the risk and the science together. Why do we need to do that though? What's the point? Well, to be conservative means the opposite. I know I'm probably preaching to the converted here, so apologies. In science and risk. In science, to be conservative means don't publish a paper until you're quite confident. And that makes a lot of sense. We don't want scientists publishing things left, right, and centre. So using this iceberg analogy, as a scientist, I'm not going to say an iceberg is present until I'm really confident, till I can see it, taste it, touch it, etc. And that informs economists, that informs policy. From a risk perspective, conservative means the opposite. You would say something, even if you're not sure, even if it's unlikely. There might be an iceberg. Post more lookouts, reduce speed, change course. So that's why actuaries and scientists is actually quite a powerful combination. So touching on Emperor's New Climate Scenarios, climate models are understating risks. As I said, this went quite viral, lots of coverage in the financial press, spoke to lots of regulators about this. And I ask you the question, why do these results not make sense? These are TCFD, TCFD is climate change scenario analysis for 3 different climate scenarios: orderly, disorderly, and hothouse. Orderly transition to net zero, disorderly chaotic transition and hothouse. And as you can see, for many of these institutions, there is a very limited difference between the different scenarios, which is intuitively wrong. And we would say that the benign results of the hothouse world are deeply flawed. Well, one of the reasons they don't make sense is the IPCC. I'm using a lot of acronyms, but I'm assuming some familiarity. The IPCC scenarios, the SSPs, shared socioeconomic pathways, use the same economic growth rate for every scenario. So whether it's a hothouse world or a net zero world, we start with the same economic growth rate, which I don't think makes a lot of sense. And this is a very famous piece of climate analysis from a very famous economist, William Nordhaus. The economic losses from climate change in a hothouse scenario to be as low as 2% of GDP for a 3-degree rise in temperature. Now, when you think about tipping points, the sort of impacts already seen, this seems fairly implausible. So how do you get that result? Well, actually, Nordhaus did a very sensible thing. He did what we do in risk all the time. Look backwards at what has happened when it gets a bit hot, people do a bit less work, and project that forwards. So by looking backwards, by definition, you have not captured any future risks which haven't occurred in the past. So although it seems sensible, it's particularly flawed. The other heroic assumption Nordhaus made was to say, well, climate change impacts the weather, so anybody who works indoors won't be impacted. So I'll exclude from my analysis 87% of the economy. If you exclude from your analysis 87% of the economy and all the risks, you get a small answer. So there's a really striking disconnect between climate science and economics. And what's happening is people are working in silos. So lots of economists looked carefully at Nordhaus's paper and said it seems sensible. No climate scientists did. So no tipping points, no involuntary mass migration, no secondary effects. As I said, 87% of the economy excluded, and also using general equilibrium models, which have a host of underpinning assumptions which just don't hold in reality. So effectively, we're looking backwards from the deck of the Titanic, April 1912, and saying it's been a smooth voyage so far. So that just doesn't seem realistic. And if you plot that damage function, we've got GDP loss on the y-axis, global temperature on the x-axis. You can see that 3 degrees with this curve, 4% GDP damage, and effectively no appreciable GDP damage, no matter how hot it gets. So that is intellectually interesting. The issue is that methodology, broadly speaking, was adopted by the NGFS, the Network for Greening the Financial System, the global kind of overarching climate regulator. They pushed that to all their members. Their members pushed that to all the financial institutions they regulate. So you have the global financial system using a stunningly flawed damage estimate and coming up with very low numbers, and everyone going either the model's useless or perhaps more dangerously, there isn't going to be much economic impact. Nothing to worry about. NGFS, to their credit, have continued to evolve their scenarios. In January this year, issued a caveat emptor statement to the market saying, look, financial institutions, our scenarios don't capture everything. You need to think carefully about what they don't capture and what you can do to adjust the intensity of your scenarios. But I think that's quite a difficult job. So that was Emperor's new scenarios, really trying to send a rocket up on the inadequacy of risk assessment. and well, I'll just say one more thing on that, and that's really, really important because risk assessment drives action. If you are walking along a path and you see a stick, doesn't matter, it's a stick. If it's a snake, you react very, very differently. So effectively, our financial models have been saying climate change is a stick, when I would argue it's actually a snake. So that led to Climate Scorpion. What to be right? This, well, emperors looked at the risk side. Scorpion is looking at the net zero or decarbonisation side. So I think of those as two sides of the climate coin. What risks might we face, and how do we decarbonise? Obviously linked. As you'll be aware, warming accelerated in 2023. With on an annual, so a 12-month rolling average, we're above 1.5 degrees Celsius now. Now that technically hasn't breached the Paris Agreement. That's a long-term average, but it's going to only go up, really, I think. Driving increasingly severe impact. So we're living in actuarial speak in the tail of yesterday's distribution. Almost certainly heading into overshoot territory. I'll go on to talk about this uncertainty in climate sensitivity, and of course the risk of triggering multiple climate tipping points. I will talk a bit about tipping points. I'm not sure how familiar you are with this. There is a bit of a health warning on this stuff as well. It's pretty powerful. So just to touch on risk distribution. So if you're not familiar with a distribution, it's a way of representing how likely something is. So if you got 100 people, you'd have some short people, some tall people, and most people in the middle. And so you could map that, you'd get that kind of characteristic shape. And what the point we're trying to get across here is, as the climate changes, it shifts the risk distribution. So that this is illustrative, but so that the mean of the distribution, the highest point, becomes more severe, more rain events, and the tail of the distribution shifts even further. So events which in 1980 would have been seen as black swans, way outside the distribution, now become more probable, more likely. So we've obviously seen a lot of floods all over the world. Now, if you aren't updating your model, you're not going to see these events. So that's something we call model risk in actuarial. Now, touching on this climate sensitivity piece, you can think of greenhouse gas levels as setting the temperature of the planet. More greenhouse gases, more energy is retained and is radiated back out into space. But it takes time. It takes time for the planet to come up to temperature. It's a very big oven, and that retained heat, that's called Earth's energy imbalance. So the more greenhouse gases, the greater the energy imbalance. Equilibrium climate sensitivity is kind of like the markings on the temperature gauge. The technical definition is, if we were to double greenhouse gases and let the planet come up to temperature, what temperature would it get to? So that's equilibrium climate sensitivity. Double greenhouse gases, what temperature do you get to? The answer is 3 degrees of warming. And so that sensitivity feeds into carbon budgets. If this is how sensitive the planet is, then that lets us calculate carbon budgets and keep, net zero carbon budgets, hopefully limit warming to 1.5 degrees. I won't talk about temperature a lot, but you can see that big jump from 2016, the blue line, up to 2023, the red line. Broadly speaking, those temperatures have increased, and as I said, over 1.5 degrees on a rolling 12-month average. This is you might be familiar with this. Various temperature scenarios. You've got time x-axis, temperature on the y-axis, and there's the 1.5 degree marked. I personally don't think it's plausible that we will remain below 1.5 degrees because we're effectively already at 1.5 degrees. So the blue line is what's called an overshoot scenario, where we go up above 1.5 degrees and then come down later. If we put on actual warming, we see that we're going up more quickly than that scenario. Well, that's all right. You say we go up and then we take the carbon dioxide back out the atmosphere, stop emissions, we'll come back down. But if you look, and this is again very actuarial, at the assumptions underpinning those scenarios, they're heroic. In many overshoot scenarios, you have to draw down annually from the atmosphere as much carbon dioxide per annum as we currently ship fossil fuels per annum. That's a lot. Lots of impacts. This here's an attribution map. So lots of extreme weather events. Red dot means climate change made it more likely or more severe. So you can see most of the events made more likely or more severe, and that's driving not just severe disruption, but also significant economic damage. So insured losses now running over $100 billion per annum, and trending upwards. A consultancy Verisk estimates, I think, a 20% chance that'll go up to $250 billion, and insured losses are probably maybe a third to a quarter of total losses, because not everything is covered. So, 20% chance of trending up to $1 trillion per annum losses. We also talk about systemic risk assessment. So we picked 4 kind of climate-driven risks: infectious diseases, food and water security, extreme heat, and then talk about the need to look at not just the hazard, likely or extreme heat events, but the response. What are governments and societies doing to mitigate and adapt to these risks? Exposure, how many people are impacted by the heat event, how long does it go on for, and vulnerability, air conditioning, water, health, and so on. And the point we're really making is that these risks are connected, they impact each other, they can cascade. So if a hurricane happens and knocks out the electric infrastructure, and then you have a heat event, then you increase the vulnerability because air conditioning isn't working, and so on. So those green environmental drivers, climate change and biodiversity loss, they then bleed into social risks, water, clearly, water stress, very real for lots of people already, the potential for multiple bread basket failure, all that kind of stuff, and that starts to impact at the economy, displaces people, leads to political instability, violent conflict, and arguably in certain regions of the world, we're already there. And then just touching on derailment risk. So that's the concept that things just get so chaotic, we're just too busy dealing with events to actually get around to decarbonising and addressing the root cause of them all. Again, risk management, traditionally, where as actuaries taught to kind of look at risks individually, equity risk, credit risk, mortality risk, etc., and then try to aggregate them. If you do that, you miss the systemic risk approach. So real need to look at risks systemically. This is the key finding of the paper. So to orient you, these are probability distributions from different climate models. Temperature, or the x-axis, and these are probability distributions of climate sensitivity. We've marked the IPCC central estimate of 3 degrees. Now, absolute full credit to the IPCC. They have done an exceptionally rigorous, thorough job. They've looked at lots and lots of lines of evidence, lots of models, and said our best estimate is 3. And then they have carefully detailed the uncertainty around that best estimate. So they would say there's nearly a 20% chance that it's greater than 4.5. Now, 20% is quite high. 20% is much higher than the chance, or higher than the chance of losing Russian roulette, which I don't think many of us would choose to play. But by adopting a best estimate basis and not considering uncertainty, that's kind of what we've based carbon budgets on. And so what that uncertainty translates into very big uncertainties in carbon budgets. So you might have seen I think carbon budgets, the net zero carbon budgets originally set back in 2018 on the IPCC special report on 1.5 degree warming were, I think, 420 gigatons, but the error margin was over 600 gigatons. So the error margin on carbon budgets is bigger than the carbon budgets. And if so, and if you, that then translates into carbon budgets being very probabilistic. So a lot of net zero carbon budgets only give a 50% or 66% chance of limiting warming to 1.5 degrees. So we kind of, in many ways, set ourselves up to have a very high chance of failure. And if you contrast that with regulated financial entities in Europe under Solvency II, European insurance companies are set up to have a less than or equal to 0.5% chance of failure. So we've taken a lot of risk with our approach to climate change. James Hansen, very eminent climate scientist, estimates climate sensitivity to be close to 5 degrees. A paper came out last week, it's a good article in the Washington Post today or yesterday, which estimates climate sensitivity to be 8 degrees. Hang on a minute. 3 degrees, 8 degrees, these are absolutely stunning differences. And what have we based our decarbonisation approach on? 3 degrees. Oh, so that's a really significant problem for me. The other problem is if you think about, say, a big project or a financial services company, every year you look at what has happened and test your assumptions. It's literally nobody's job, although lots of scientists are monitoring stuff all the time. It's nobody's job to say, hey, temperatures have changed, we have more information, we need to update our carbon budget. So in financial services, everybody's using carbon budgets, which are 6 years out of date now. Tipping points, I'm sure everybody's heard of tipping points. But if you can think of it as, back when you were at school, swinging on your chair and you're very stable, as long as you don't swing too far, you'll come back to upright. If you swing too far, over you go. The whole class laughs at you. It's very difficult to get back up. The Earth system is full of tipping points, complex adaptive system. Some of these are very material in terms of either accelerating climate change or accelerating climate impacts. So if you take the Greenland ice sheet, as it melts, it reduces in height. As it reduces in height, the temperature increases till it tips into irreversible melt. Now that's going to take some time, but it would add, I think, 7 meters to sea levels. So even if a relatively small amount of it melts much more quickly than expected, it's still going to boost sea levels a bit. That pulse of fresh water goes and disrupts the Labrador current, and that starts to disrupt this thing called the subpolar gyre, marked by E on the map there. And then you start to potentially mess with the Gulf Stream and the AMOC, the Atlantic Meridional Overturning Circulation. Scientists estimate that if the SPG is disrupted, the Gulf Stream is disrupted, the crop growing season in the Northern Hemisphere shrinks by a matter of months. So we're looking at very serious implications in terms of our ability to grow staple crops. Those ocean currents go down and impact the Amazon tipping point. If you only consider climate changes through best estimate 3 degrees Celsius. So 3 degrees Celsius, the Amazon tips from rainforest to savanna. But when you take into account deforestation, we've deforested roughly 17% of the Amazon, that tipping point reduces to closer to today's temperatures, 1.5 degrees Celsius. These tipping points are not independent, they're linked to each other, they can cascade. So this is really the point that we mustn't go past. If we tip over and start to trigger these multiple tipping points, it's going to be incredibly difficult to limit global warming. I won't go through all of those now, but 5 letters A, B, C, D, E, those are tipping points which are close to or tipping at current temperatures. Something which isn't marked as a tipping point, but which is a very powerful feedback loop or feedback amplifier, is Arctic sea ice. As the ice melts, you lose reflectivity and albedo, and that ocean water absorbs heat more quickly, and so you have the Arctic warming 3 to 5 times more quickly than the rest of the planet. And again, that's starting to disrupt the thermal gradient of the planet, the significant jet stream disruption driving some of these events we see. So what the heck do we do about this? Well, realistic risk assessment of climate change is absolutely critical. If we have these very flawed risk assessment techniques, then policymakers are not getting accurate information, and so they're not acting on it. Education on positive tipping points, which I'll talk a little bit about, but I'll also talk about planetary solvency. So putting in place a kind of structured framework to help policymakers to make decisions, and last but not least, looking at these net zero carbon budgets and assumptions. So as I've talked to, we're already at 1.5 degrees. Emissions are still high. We're losing reflectivity. There are other impacts too. So there is, in my view, no way the temperature cannot continue to go up. So that means net zero carbon budgets, or carbon budgets designed to keep warming to 1.5 degrees, are now negative. Whose job is it to get that message out? The answer is, it is nobody's job. It's a politically difficult message, but continuing to ignore reality is not going to be helpful in the long term. Positive tipping point. So right hand side, the classic kind of S-curve of tech disruption and growth. We've seen that in mobile phones, horses to cars, all sorts of human technology disruptions. They tend to move much more quickly than anyone anticipates, particularly when supportive policies are in place. And we're starting to see these positive tipping points in renewables, electric vehicles, the cost of solar, the cost of batteries, and so on. And this is from the fantastic global tipping points report. The idea is that if we can, for example, lower the cost of batteries, that then feeds into cheaper electric vehicles. That then helps with low-cost storage because they can connect to the grid. We could maybe have some supportive policies to incentivize that uptake, and so on and so on. So there's real hope and opportunity to move much more quickly, just to give some positivity here. So what would realistic risk assessment look like? Again, this is temperature on the x-axis, GDP damage on the y-axis. The big difference is GDP damage goes up to 100. That grey line at the bottom that you can see just creeping up from the x-axis, that's the Nordhaus damage function. No appreciable economic damage, no matter how high the temperature goes. I just think that's implausible. So we propose, and hats off to Professor Steve Keen for this, coming up with usefulness, something which we use all the time in financial services, reverse stress testing. What the heck is reverse stress testing? Reverse stress testing is a process where you think about what could cause insolvency, the risk that would cause insolvency, and think how to mitigate those. So we're saying work backwards from ruin, 4 degrees, 5 degrees, 6 degrees of warming, and the end point doesn't matter. We could discuss all week at what temperature society has lost, etc., etc. The point is you start to see much more significant damage even before 2 degrees as you go past 2 degrees. So the point is trying to get across that going past 1.5 to 2 degrees is incredibly dangerous. As you start to trigger multiple tipping points, there would be economic damage, in my view. So I'll finish on planetary solvency. Want to leave time for discussion. I'm sure you all recognise this, that the Earth system is the foundation for our civilizations. You've got an alternative depiction of the SDGs, the Sustainable Development Goals, the biosphere on the bottom. Society rests on nature, the Earth system, the biosphere, and the economy rests on society. You can't have an economy without society, and you can't have a society without the basics of life, food, water, energy, etc. So this is, if you read the Dasgupta review, very Dasgupta-ish. So we have planetary boundaries. Those are our solvency limits, effectively. So can we leverage risk management techniques from financial services to come up with a way to communicate planetary risk better to policymakers? When do we hit ruin? What are different levels of risk? What should our risk appetite be? And what action do we need to take? So that's the next paper. Hoping to launch it pre-COP. And just to touch on a climate change example, planetary solvency might say, well, really 1 degree of warming is a kind of safe, just level of warming. So rather than using unrealistic carbon budgets, which aren't going to limit to 1.5 degrees, let's get realistic and let's set some long-term targets. Let's get a plan in place to get back down to those kind of safe temperatures. Right, that's the formal bit over. I appreciate I've chucked a lot at you there, so I'll open for any questions.